This is paper 3, video 3 for the February mock. First question we're going to look at here is all to do with ratios. So in order to decide which part of ratios you need to do, you need to read the question very carefully each time. So here we've got that the ratio of pupils to staff on a school trip is 9:2. So for every 9 pupils there needs to be 2 members of staff. So all I would do for a question like this, because it tells us here that there are 45 students, so it is telling us what one part of the ratio is actually equal to in real life. So at that point what I would do is just write down the ratio. So pupils to staff, it's the ratio 9:2. It's telling me that there are 45 students of 45 pupils. So all I'm trying to look for here is an equivalent ratio. 9 times 5 gives us 45. So I'd have to do 2 times 5 as well to give us 10. So these two are equivalent ratios. So for the 45 students, we would need 10 staff. So the answer here is 10 staff. For the next question, very similar. So using the same ratio as above, Mr. Rimmer said that we can have 7 members of staff on the trip. So if we do the same idea, pupils to staff, the ratio is 9:2. Now if there are 7 members of staff, here we have multiplied by 3.5. So if you do the same with 9, multiply it by 3.5, that gives us 31.5 students. Now you can't take 31.5 students on a trip. If I rounded up, the ratio would be too much. So I'd be over the limit of number of students. So here I'm going to have to say that the safest number of students that can be taken is 31. So rounding just down. The next question is asking us to simplify some index laws. So whenever you're doing index laws with brackets, there's always going to be 2 parts to your answer. Something with the number at the front and then the power part at the end. Now the power part at the end is actually the easiest bit. When you've got a power inside your bracket and just outside, all you do as a little cheat is you times the 2 powers together. So this would give us b to the power of 12. In order to work out what number needs to go at the front, we actually need to do 5, the number that's in the bracket at the front, to the power of 4. You can either use your calculator, or you might know that 5 to the power 4 is 625. So it would give us that the answer is 625, b to the power 12. For the next one, same idea. You can times the powers together, so it gives us v to the power 15. We then need to do 2 to the power 3, so we do the number inside to the power that's on the outside of the bracket. 2 cubed is 8, so we just put that at the front of our answer to give us 8v to the power of 15. Same idea with the last one, m to the power 4, cube it. We simply times the powers together when there's brackets. And then we would need to do 6 to the power 3. 6 times 6 is 36, times 6 again gives us 216. So we get 216, m to the power 12. The next topic is looking at means. But this time, instead of just asking for mean from a list of numbers, it's using the fact that we've been given the mean scores and we're going to try and work in reverse a little bit. So a maths test is completed by a class. 12 boys got a mean score of 45 out of 60. So the first thing I would do is actually work out what the total score of all of the boys are all together. So if there are 12 boys and all together they got an average or mean of 45, so we assume on average everybody scored 45. 12 pupils getting an average of 45, so 12 times 45, that would give us 540. So that is the total score for all of the boys. We do the same idea for girls. Now it tells us that there's 18 girls. They got an average of 41 each. So if I did 80 times 41, again, use your calculator, that gives us a total of 738. So that's the total score by all the girls. Now we need to try and find the average for the entire class. So the first thing I would need to do is add together the total scores for the boys and the girls. In this case, it's 1,278. That's the total score by the entire class. Now there's 30 pupils in the classroom, we know that, because there's 18 girls, 12 boys, so 30 pupils altogether. So to work out the mean for the whole class, we'd need to do 1,278 divided by 30. If you put that into your calculator, you get that the average score for the class is 42.6. Now the question actually asks for a little bit extra then. It says that the teacher is going to keep their job only if the class has got a mean of 43 out of 60 or better. The class has got a score of 42.6 out of 60, therefore no, the teacher does not keep their job. So no, the teacher loses the job. Potentially a little bit harsh, but that's the way it goes. Next topic is all to do with a time graph. So here we've got a paper aeroplane has been thrown out of a bedroom window by Mr. Smith. The graph here shows the height of the plane above the ground over time. So all we need to do for these questions is read some values off the graph. Part A wants us to find out how long the plane is above 5 metres from the ground. So all I would need to do is find at what point the plane goes over 5 metres. So reading across from 5 metres here, it starts at 12 seconds, and then at 14 seconds it then dips again below the 5 metre mark. So from 12 to 14 seconds after the time that the plane was thrown out the window, it's above 5 metres, so overall it is just above 5 metres for 2 seconds. We then need to work out how long the plane is lower than its starting point. Well, it started at 3, so for the first chunk of the journey it stays above the starting point when it was thrown out the window. At this point here, which looks to me to be roughly 17 seconds, so at 17 seconds it dips below where it started at the window, and then that keeps flying all the way up to 23 seconds. So in my reckoning, 17 to 23, that would be 6 seconds. Final question, it wants to know how much the height has changed between 7 and 13 seconds. Now this is asking a slightly different thing, so at 7 seconds I would read off, so just here at 7 seconds it is 3 metres above the ground. At 13 seconds, which would just be here, the height is just a little over 5, so I'm going to say 5.2, looking at the scale of this. So how much has the height changed between 7 and 13? From 3 up to 5.2, that's a change of 2.2 metres. Final question for this video is all to do with depreciation, or more importantly, percentage change. So here we've got that Mr. Smith has bought a sports car for £30,000. Now here where it says depreciate by 13% a year, that basically means that it has lost 13% of its value, and it will keep doing that just like compound interest with the value at the end of each year. So we're not just going to find 13% and times it by 5 to do the 5 years. We need to find 13% and knock it off each year, then find 13% of that, knock it off, and so on. Now that could take quite a bit of time, so there's a much quicker calculator way of doing this without having to worry about that. If the value we assume starts at 100%, if we take 13% off, we are left with 80%, 87% of the value of the car. Now, to very quickly do this on a calculator, all we would need to do is change that 87% into a decimal. So if we take the value of the car, which is £30,000, times by 0.87, what that would do is find the value after 1 year of the car. Because we are doing this for 5 years, we do the 0.87 to the power of 5. If you type that into your calculator, you should get an answer of £14,952.63. Don't forget your pounds at the front and round to 2 decimal places. For the next question, Mr. Horn is buying a jet ski. It costs £12,000. It depreciates by 20% for the first 2 years, and then we've got a little change, 15% every year after that. So if we go with the same idea, for the 20% one, it drops by 20%, and as I mentioned there, that would mean it goes down to 80%. So for the first section, we would have to take £12,000 multiplied by 80% as a decimal is 0.8, and because it's doing that for the first 2 years, we do that bit to the power of 2. Now, instead of making a bit of a mess and doing a lot of different answers, I'm then going to do the 15% drop at the same time. So if we imagine again, every year that it happens, we assume that we go back to 100%. We're starting with the full value. Take away your 15%. So each year we are going to be left with 85%. So 0.85 is the decimal for that bit. And because we are doing that one for 3 years to get up to 5, we would type that into the calculator, and that actually comes out as an answer of £4,716.48. The final question has thrown a little bit of a curveball in. So Miss Trail is buying a camper van, £20,000. This time though, in the first year, it increases by 9%. So if we show that increase, so 100 plus 9, because it's an increase, is 109%. As a decimal, that would mean we needed to times the £20,000 by 1.09. We are only doing that for 1 year, so I'm just going to leave it as 1.09. It then says it depreciates by 6%. So a 6% drop would mean we need to do 100 take away 6, which is 94%. And again, we are only going to do that for 1 year. So if I then times by 0.94, because that's the same as 94%, it will give us a value of 20,492. Don't forget your pound sign on the front.